Yo, this is Mike. Sorry for the rough intro. Just a quick video here on Speed Queen. Actually, this is for the Speed Queen commercial dryers. Without further ado, let's get into it.
To the Alliance Laundry System Virtual Service Summit for fall 2020. I'm really happy to be here this evening. I hope that everyone finds this a really great use of their time. It's the end of the day here in Wisconsin, and I've been talking all day, so I will try my best to not lose my voice, but I hear a little rasp coming through.
Yeah, it sounds like it.
You should be able to hear us at this point, which doesn't make a lot of sense to say out loud, because if you can't hear me, that you're not going to be able to hear me say that. But that's why we have these slides. If you cannot hear, or if you're having any kind of sound issues, please make sure you have the correct audio selected, and also make sure that you have our cameras at this point. And we are going to, can you select the presentation again for me, please?
Let me hit that for you.
Thanks.
There you go.
We're going to go over a few rules. Microphones will be muted just because there's a lot of people on the call today, and we don't want things to turn chaotic for you. So if you need to interact with us, again, use the question box. Ask as many questions as you like. If you ask a question about information that's pertinent to what we're discussing at that moment, then we may interrupt the webinar to answer your question. If you ask a question that I think is best served, or maybe a little late and we've our time. And Q&A is
actually on a stack unit. A lot of capacity for a small footprint. But I want to move into how we support the cylinder, meaning as the cylinder rotates, what's holding it in the cabinet. So I'm going to take off the front panel. And this is a nice casual. It's basically me manipulating the drawing live. So we can, with that in mind, Dustin, if you have something you want to see out there a little closer, just type in the question box and Dustin will let me know, right, Dustin?
Absolutely.
About stuff like that. So I just highlighted and removed the roller bracket. You can see the front of the cylinder on these axial styles, or the stack tumblers, is supported by two rollers. We're going to talk about that in commercial quality, and we're also going to show a video down the road looking at how to quickly and easily change those. So on these axial style tumblers, the front of the cylinder is supported by two rollers, and then the rear of the cylinder, I'm pretty close here, it's a little angled, but we can live with that. There we go. This is the actual shaft coming out the back of the trunnion of the cylinder, and that's the bearing that supports that. So these cylinders are supported by three main points. When we talk about the cylinder itself, how it's supported, let's now move into how we rotate the cylinder, how we drive. So we have a dedicated motor mounted on the back, and we call it the bottom left-hand corner from the rear of the machine. Has a motor pulley on it that's driving this belt that goes around the cylinder. On current design premium tumblers, We have two idlers. You have a stationary idler and a spring tension idler. It's a little different from maybe designs of past where we had a single idler arm or idler pulley. We have these twin idlers now because these machines are actually reversing capable. So that's the way we're set up now with the drive. Again, it's a very, very simple, very few moving parts. And when we understand more about how this machine works, you'll understand how this belt is built for longevity. So moving away from one of the two main things a tumbler does, and that's provide movement. It runs. We'll look at heat. So we do movement and heat. So the heat on a stack tumbler comes from inside here. This is what we call the stove assembly. Obviously, on a stack unit, you've got two of them, and they're identical. One heats the lower pocket, and one heats the upper pocket. That's what we call that, pockets. Let's zoom in a little bit here. If I remove this rear panel of this stove assembly and the internal rear panel, you can see what I've highlighted in red right there. That's the actual burner tube. So the gas valve is supplying gas at the front here at the port through this spud adapter. Gas along with oxygen or air, that's where we light up the flame, and that's providing us our heat. So that's located on the rear of the machine. We'll talk about airflow for that in just a second. Let's talk about the fan slash blower. So I'm just going to go down a little bit from the heat source. You'll see you have a dedicated fan motor right here that's connected to an actual fan right there internally in the machine. So dedicated drive motor, dedicated fan for very specific actions. So your motor action is the drive and the fan, and then the only other thing the machine does is heat. So we'll break that down a little further. Lastly, you have your electronic components in the machine. You have an output board in the premium line, and you have a front end control. We have an output board because on the premium line, we're running inverter driven motors. And finally, other electrical components, you have an ignition control module and the gas valve. So just, really good, unique looks. I'm gonna do my best to bring that back up. Dustin's gonna remind me because it's a nice look at the machine. So we looked at the main components. This is what we looked at, the cylinder, how the cylinder is supported, how we drive the cylinder, where the heat is located, the fan and blower housing, and finally the electrical components. So after that, there's really nothing left of the machine other than fasteners and paneling, maybe a few seals. But the idea to show this to you like this and display this information like this is to let you know there's really not a whole lot to the tumbler. Electrically, mechanically, it's pretty easy. Where we start to have question marks or maybe get lost here from a human standpoint is understanding how critical airflow is for these tumblers. So we'll move into that a little later on down the line. But keeping up with the theory, we're going to look at a video that Dustin and I produced at the start of the year, end of last year, start of this year. A video I essentially always wanted to make. It's a video on airflow for tumblers. We took a section out of it to basically, again, just fortify how these things work. So it's about 1 minute and 1 second. So I'm gonna plug it now.
Tumble dryers remove moisture from the load by the process of evaporation using a combination of airflow, heat, and tumbling action. After a cycle is selected and the tumble dryer is running, the tumble dryer control monitors the thermistor for the temperature. Based on what the thermistor reads, the control either turns the heat circuit on or off. As water evaporates, it lowers the temperature of the air. This has a heavy effect on what air temperature reading comes from the thermistor. Early in the cycle, the garments are more saturated with water, so heat on times will be extended to make up for the heat loss due to increased amounts of evaporation taking place. The fan pulls air in through the heating assembly, referred to as the stove, and heats the incoming air. The heated air moves through the rotating cylinder. The air then passes through the lint filter, exhaust fan, and is vented outdoors.
So a real quick look at that. Some major factors that we just want to highlight that was shown there, and that is The three main things for drying are airflow, heat, and movement. As we go
Seems
through
pretty
more,
simple when you break it down like that, right?
it does, but I think I alluded earlier, like we can't see air. So air being the most critical of the three, since we can't see it and we have airflow problems, we run into, basically we're chasing a ghost. So keep that in mind. The other thing too that highlighted in that little 1 minute section of the video was that when evaporation takes place, because that's what we're doing, we're evaporating the water from the garments, but when that happens, you lower the temperature of the air. So for theory, understand we bring heat in and try and get airflow through the garments, and as the heat raises, well then we have evaporation taking place, we offset that heat. So just stuff to keep in mind. One thing too, I think I got a slide where I just want to talk, like, here's how air flows through the tumble dryer. So the atmospheric air that's supposed to be from your makeup air from outside is drawn in across the burner, through the stove, the box, over top of the heat source, and then through the perforated rear of the cylinder. That means the rear of the cylinder has holes, and that's where that air is drawn through. It goes directly through the cylinder, down through the lint screen, or in the lint drawer through the lint screen, and then eventually through the fan and up the stack in the back to the vent. So that's the path. It's a very concentrated path of heated air that is very efficient for this size and style of tumbler, and that's why we go this route for these styles. So, or for this size and style / application for a vended laundromat. So along with the theory here too, we've included just a few parts, because we're going to talk about these parts down the road in error code or error troubleshooting with when you get error codes, but also they're absolutely fundamental in everything we're trying to do. So I've said before, airflow is the most critical. We have a switch that monitors just the airflow. It's located, Dustin did a really good job of these slides, it's located, as you can see here, right above the blower motor. It's posted to the back of the cabinet of the machine. Basically, it's posted to the wall that is the back of the cabinet right behind the cylinder. So looking at it on the left there, the top part of it that's highlighted in red, that's the actual micro switch, the switch that's either closed when the damper is drawn shut or open when the fan stops and the damper is just hanging. So this little video clip on the right shows being drawn shut right now when the fan starts, and then when the fan stops, gravity pulls it back. So we're verifying that we have airflow. If we don't have airflow,
yeah,
right, we don't want the heater to turn on. We have to have proper airflow, and the controls now do a very good job of monitoring this airflow switch and its function to prove that it's working properly. If not, we will have issues. So we'll talk about that. Let's see what is going on here. So I've lost control of my presentation. Sorry, everybody. Moving on from the airflow switch, it touched a little bit in the video of the thermistor. Like the thermistor is used by the tumbler to determine accurate temperatures, and it is very, very accurate. The thermistor is located on the secondary side of the fan. What that means is, as your fan turns, you have a minus side and a plus side, so to speak, where air is being drawn into the fan and where air is blowing out. The air blowing out is what we call the secondary side. Air coming in via the fan, the vacuum is the primary side. So we locate the thermistor on the secondary side of the fan for a couple of reasons. I don't know if my counterpart remembers any of them or if I should just keep rolling with this. Do you want to explain to him, maybe, Dustin, why it's on the secondary side, or at least your take of why the thermistor is on the secondary side?
So if you actually had a bunch of thermometers within a cylinder that was moving, and you had the heating element pulling in fresh makeup air and heating it and then whirling it around the cylinder, is actually not that consistent. So you're going to get widely varying temperatures based on the location of the thermostats within the cylinder. The most consistent measurement for actual air temperature is going to be where it's located on the back end right before it exits through the exhaust.
He's right. He's right. He just forgot one part, and that's
Oh.
evaporation taking place.
Wow,
That's
call me out.
cooling there. Yeah, I'm gonna call you out in front of these people. All right.
Yeah.
We need you to understand this
Just
stuff,
be
Dustin.
tactful about that. Had to just blatantly call me out.
So he's right though. The way he said it was, if we took a measurement inside the cylinder, it would be widely varying. You've got raw heat coming right from an open flame as it swirls around through the cylinder, and also you've got evaporation taking place. Another part in understanding the thermistor is that it connects directly to the tumble dryer's controls, and it gives a reading in resistance. Not to get too scientific for those of us who don't understand, that's fine. It's not meant to be that way, but it's some real simple science in that cool air has more resistance, hot air has less resistance. Example, this thermistor would read about 50,000 ohms resistance at, say, 75 or 77 degrees, where at 190 degrees Fahrenheit, we're reading more like 5,000 ohms. So there's a big range there too, but this is really, really accurate. So it's a really important part of the machine. That's why we're taking this time with it. And also understand that connection from the thermistor to the controls, we use a pair of twisted black wires. And together, the wires in the thermistor itself, we refer to as the thermistor circuit. The wires are just as important as the thermistor because they deliver the signal that is being read by the thermistor. Just a note there, if we've got a little bit older machines, instead of black and black, you'll have a black and white twisted pair. Okay? Another component in the unit that we focus on, because we're going to look at a few things of that today, is the highly, yes,
Quick
sorry.
question.
Sure.
So we got a question. When do you have to replace the thermistor? Is that
somebody's ahead of the game here.
They
But
are.
that's good though. That's good though. That means we're presenting in a fashion that's leading them to the right questions. There, did I pat our back hard enough on that one,
yeah,
Dustin?
he could just be smart too. So that might. I don't think we need to steal that thunder yet.
There's two examples at the end in the error code management that will talk about that. So
stay tuned.
Stay tuned. Thank you. Moving forward with another components used in the tumbler are thermostats. In the old days, we used to use thermostats as cycling thermostats, but they're not incredibly accurate and they have a lifespan to them. If they're used repeatedly, they wear out and fail open and we can't use them anymore. We need to replace them. Thermistors don't fail quite like that. And like I said, they're way more accurate. So now we use a thermostat as a high limit safety feature where we place it strategically in the tumbler to monitor areas of the tumbler, and that if it gets too hot, this thermostat will open up circuitry and relieve power or take away power from our heat source, i.e. The gas valve. So these thermostats are strategically located, like I said, two main areas. We'll look at them in depth here. Again, some pretty good graphics. Two thermostats on your stack tumbler are actually located on the burner assembly or the stove assembly. So those two thermostats up top there are called stove limit thermostats. They're facing the flame or the heat inside the stove, in that if we ever had poor airflow and air wasn't being drawn through the stove like it should, these thermostats are our savior. They should keep that from getting too hot. They'll open up, the gas valve will lose power, and we won't keep heating because it's not a safe environment. Another location, as you see on the bottom there, right next to the thermistor, is that another thermostat that we call the cabinet limit thermostat. If you've got newer units, newer premium design units, there's actually two thermostats there too. There's a auto reset and a manual reset. Maybe we should look at those on the drawing. Let's do it. So I'm not giving you the option, Dustin, right? We're doing
Yeah,
it.
I can hear your tone. I know what you're hinting at.
So let's
This
look at this.
chronically throwing me under the bus.
Just get out of the way. When you look at, I already took the back panel off the heating assembly or the stove. Here's one of the stove limit thermostats, and the other one, actually, if you look at the wiring diagram, for those of us who do a little of that, this one I got highlighted in red right now is called stove limit 1, and the one looking at it from the back is called stove limit 2. I'm going to scroll out and down just a little. And if we look here as I tilt it, this is your thermistor that actually does your temperature reading. But here's a manual reset, or excuse me, an auto reset. That's auto reset, cabinet limit thermostat, and here's a manual reset. So strategically located, these two are located next to the thermistor. So if we ever had a false reading on the thermistor for whatever reason, this would be our savior there. So again, easy to locate on the machine, and with this rendering, it helps us quite a bit to do that. These thermostats have a life to them, like I said, and this is a really, really important statement I'm making here at the first half of the webinar, in that if a tumble dryer is properly installed and maintained, these limit thermostats will never, ever once turn on or off, or excuse me, cycle off, and they should never need replacement, meaning if we've got bad airflow and the stove limit thermostats are chronically cycling off, then cooling down and coming back to shape and turning back on, eventually they wear out and you need to replace them. The statement here on this slide is, if things are done right and you take care of business, these should never once cycle. So keep that in mind. I've been quoted before, is when I train our in-house staff, if someone calls looking for a part number on a stove high limit thermostat or cabinet high limit thermostat, I try to get them to ask questions, or at least let the person know, hey, those should never fail. If they're failing, that tells me something's the matter with your machine environment. And when we use the word environment, we're talking about installation and maintenance. So that kind of tidies up the theory of operations section that we wanted to do, just so we understand how things work. And now moving forward, we're going to go into the quality of the machines and how this all kind of plays a role. This is Dustin's favorite part. I think as we get started here, Dustin's got a true or false poll question for them.
I do. So this is kind of a trick question. We haven't talked about it, but I just want to see where everyone's at here. So true or false? The term commercial is regulated by the US government when used to describe laundry equipment. True or false? The term commercial is regulated by the US government when used to describe laundry equipment. True or false? Like,
I always like to
makes
see
you think,
responses
does the government controls a lot of, like, can it say organic on our food?
Right,
and it has to reach certain standards in order to do that. All natural is not something that is regulated by the government. Did you know that?
Yeah, and along with that, to add to your little banter here.
My little banter, thank you.
What was it? Natural flavoring doesn't have to be identified anymore either.
Yeah, it's crazy.
All right, this is getting political. Let's just go
All
ahead.
right, we got to calm down
up
here.
there. Yeah.
All right, so we have 41% thinking this is true, that it is regulated, 59% thinking false. So the majority of you are correct.
Right.
This is not regulated. So, Andy, could any manufacturer create any washer and dryer and call it commercial simply because they want to enter a commercial space?
They could. And you could even say, I don't know, a 5-gallon, using inverters on washer coolers to support the cylinder versus a rear.
We define what commercial means to us. And actually, in this little video reel that's playing, Andy knows that guy pretty well, and I went to high school with that girl. So Ripon, Wisconsin is a city of only 7,000 people.
That's where you're going all wrong with it. You're calling it a city.
Yeah, well, it is the
that's a
city of
town.
Ripon.
Yeah,
It is a
it's
small
not
city, and so it is very much a. When I walk through the factory, I see people that I haven't seen in years, but I grew up with and stuff like that. So
Yeah, it's real. It's a real place. And again, I know some folks on the call here today that have been there. They know it's real. It's everything we're
yeah,
showing you and
it's
telling
not
you.
like
Yeah.
Narnia, right?
Right.
Hogwarts.
So,
Right.
first thing we'll talk about when we look at this size machine we're focusing on today, the stack units with the axial. We looked at in the 3D rendering how we support the cylinder, and we use rollers to support the cylinder versus a rear long dual bearing shaft trunnion. The reason we do that, they provide a more even support for the cylinder that is actually proven to increase longevity, which is critical in operations, especially in a vended, to heavily used tumblers. So machines that see a lot of turns, rollers have proven to be more cost effective in use for this style machine. Another thing too, why we're all here, I mean, this is a service-based webinar. It is very easy to service, which helps keep our maintenance costs down and our downtimes for a malfunctioning machine. Those times down should be shorter. And we'll show a video, a actual 360 video of how to change a roller. So we'll look at that. So again, tying into the commercial quality, how critical that is from a service standpoint as well. So when we look at the new premium tumblers, we are using what's called proprietary inverter drive. So we've been using inverters on washer extractors for coming up on like almost 4 decades. We just started using them on tumblers, and they have proven to be incredibly beneficial for a number of reasons. Number one, before an inverter driven motor, we actually had just single speed motors, which the difference is an inverter driven machine or motor has an unlimited number of speeds, so we can program how the machine turns, versus a fixed speed motor. It's either on or off, so we tell the machine to turn on and the motor tries to go, and to come up to speed requires quite a bit of amp draw, quite a bit of power. So the first benefit to using an inverter driven motor on a tumbler is it has a soft start. You press start, a little delay in processing, and then slowly it comes up to speed. That provides us with a really, really low dB operation, meaning it's super quiet. Tying into the soft start stop, that also gives us a longer belt life. We're not asking the machine to turn right away, so we're not jerking the belt. We're actually just ramping it up real slow.
Pause.
So
Pause.
from an operational standpoint, we get the idea what's going on, quieter, easier on the components like your pulleys and stuff like that, your motor. But this brings something else to the table that, you know, a lot of people don't think about, and that is improved diagnostics. When you have an inverter control, like we're showing with the arrow pointing up there, this actually acts as a monitor for the motor now too, and it actually acts as a monitor for the incoming power to the machine. So by monitor, I mean if the belt ever slipped off or something like that, which is very uncommon, but let's say we had a belt problem or one of the pulleys bearing got seized or whatever, the inverter can actually read the amp draw through the motor and determine that if there's a problem, like, hey, this is way too easy, there must not be any tension, we must be missing a belt. Or the flip side of that, we've got a seized bearing on an idler shaft, or on the shaft itself is actually seized. Sorry, there's no bearing. And we have too much pull, it can see that too. So that's really neat, and it translates directly to the front end control and gives us an error code. Also tying that back into the soft start and stop, we don't have the belt slip, so we don't have belt dust and stuff like that. So very beneficial. Also, keeping up with this diagnostics bit of business here, aside from the inverter, the controls on the premium line tumblers actually possess the technology to self-diagnose all these safety switches in the heat circuit. Competitor tumble dryers can only diagnose whether the machine is heating or not. So what we're saying there is, if you look at the diagram on the right, I don't care if you can't read electrical diagrams. That's not the point here. The point should be pretty simple here. The right side of this, it says control in big gray letters. On the left, it says switches, and that's what they are. When we look at the heat circuit, there's a bunch of safety switches that have to be intact before we can ever operate the heat. So the way things go here is when the machine calls for heat, so to speak. Oh, I want a pen. Like to start this heat circuit, we send signal out through the airflow switch, and then that signal comes back directly into the control. If we follow that signal, and then it goes out to the auto reset cabinet limit thermostat, and then it comes back in. So the fact that each switch has a wire in, wire out tells us that the control can monitor each one of these switches individually. Therefore, if we ever have a problem with one of these switches, we will generate an error code specific to that switch. Like it says in the bottom statement, competitive thermal drivers only diagnose whether the machine is heating or not. So it's basically an in-series circuit where we send this one signal out and it goes through all those switches in a row and then winds up at the gas valve. Well, if one of those switches has a problem, we have to diagnose that individually with a voltmeter, and we really have to know what's going on. So this is all about, this is a commercial machine. It needs to stay running. This should help us immensely in our efforts to keep the machine running.
Is the inverter motor actually more efficient as well, Adam?
That's where it starts. That's where most people go, oh, it's got an inverter. That means it runs much more efficiently, less cost of operation. Then we think that's where it ends. But my point in that is that also with inverters and these type of electronic controls, we get all these diagnostics as well. So good point. Along with the ability to check safety components or the switches, these tumble dryers also provide specific error codes for stuff like the ignition circuit. Your spark igniter, it's got a sequence to it. Once the flame is lit, where actually there's a circuit internal to the ignition circuit that proves that the flame is there. It can monitor that too. Also, your components in the machine that use electricity, like your loads, like a gas valve, you give it power and it energizes to allow gas to go through it. Like that's a load. We can actually determine if it's operating inside its normal range. So we can see switches, but we can also monitor loads. So troubleshooting is really, really simple on these, provided we know what these error codes are. We find the error codes in the programming manual. Dustin, I think, has a nice section towards the end here where we can help you find the correct programming manual.
Absolutely.
Yeah, which will help you with these error codes. But the point here is, before, like, if we had a no heat condition, which means we have component failure, we really had to have it together, or we'd have to call a technician. Now with this current system, it's going to produce an error code that might say something like, hey, you particularly have a stove limit thermostat number 1 is open. And we can go look at that. And like I said in a previous slide, if we have one of those open, that means I got an airflow problem. So it's going to point us in the correct direction with some simple interpretation. So moving more into mechanics of the machinery, you see here it says perforated baffles. We talked about what baffles are in the cylinder. And I think if I go like that and like that, we'll stay right on this slide. When we look at the care tag on bulky items like comforters or big sheets or sleeping bags, stuff like that, those care tags, as far as how to take care of that, usage, would tell us wherever drying these, they should be dried on a maximum of low heat. Some even call for no heat. And that's due to the nature of a tumbler, air flowing through the tumbler and out the lint screen. These big bulky items run the potential of blocking air coming out of the cylinder, where it eventually goes through the lint into lint screen and to the thermistor, where we do our temperature readings. These bulky items can block that. So to avoid that situation, which could cause damage to the garments, the Alliance product actually has perforated baffles that will counter that. So if the front half of the cylinder gets kind of choked off by something, the air trying to get out will still escape, as it's shown here, through these baffles and then out the caps of the front of the baffles to equalize that scenario. Here's an even better look at it. So that air that we're trying to get out so we can read it properly goes through the baffle, out the sides of the outside, and eventually to the thermistor. Absolutely critical. Keeping up with the cylinder, those perforations I keep talking about, the perforations in the front half of the cylinder specifically, are oval. All of them are oval, but it's really important on the front half. Because for whatever reason, every American male, some American females at any given time have, it could even be mysteriously, have drywall screws in their pocket, it seems like. So a drywall screw, straight up and down, can get held up in these perforations, but if the head turns at all, it falls through because it's oval. When you turn the cylinder, that's exactly what happens. There's a look at it from underneath. If that's not allowed to fall through, it's going to stay in the cylinder, and eventually it's going to scrape around the inside components of a tumbler. So as you can see, it just simply falls down on these stack units right on top of the lint screen, harmless. If we had other manufacturer cylinders where they don't allow the screws to fall through, we can scratch those internal walls of the cylinder of the tumbler, and not just provide us an awful screeching noise and knowingly damaging the machine, but if they let it go bad enough and it cuts the side panels of the machine, now we're going to draw in cool air that goes directly down to the thermistor. So the thermistor will essentially be continually fooled, and it'll just keep giving heat input, and we run the risk of scorching garments and such. So that closes out that section. Dustin's good at this. He's got a little quiz for us all.
There are no
Pop quiz.
All right, let's move
So-
on to the next section.
We have hinted at this a few times throughout the presentation so far. Tumble dry.
1/4 inch or 6 millimeter feet, and it's
All right,
Completely ruined the presentation. Here we go.
here we go.
So first things first, when we look
Hey,
at
hit the
PM,
damn mic button.
let's
That's
get
what's
some more
first.
understanding of just how critical venting and makeup air is, and what type of symptoms we would have if we had poor airflow. So this is like, I think we're up to 2 minutes on this one. So we'll catch up with you here in just about 2 minutes and go over some of what was displayed here. So stand by.
Now that the drying process and airflow principles have been explained, let's examine the installation requirements for venting and makeup air so we can see how critical these are to tumble dryer performance. The primary task for venting is to move air out of the tumble dryer at the same pace it's being brought in by the fan. For maximum efficiency and performance, it's recommended that each tumble dryer be vented to the outdoors individually. On an individual vent, the overall length should not exceed 14 feet, and it should not have more than 2 90-degree elbows. When individual venting is not an option, tumble dryers may be collectively vented into a manifold. However, it is very important to understand that manifold venting must be precisely designed and will likely require more maintenance. If the venting is insufficient, the airflow through the tumble dryer is decreased, and this leads to several problems with the tumble dryer's performance. Insufficient venting will accumulate back pressure while tumble dryers are running because the airflow is obstructed and not allowed to easily exit. Each model tumble dryer has a maximum allowable back pressure rating. If the back pressure rating is exceeded, it is more than likely that the tumble dryer will have service issues and/or excessive lint accumulation. This rating can be found on the warning label that is present on the rear of all tumble dryers. When it comes to diagnosing questionable vent work, a tool called a manometer is used to see if the maximum allowable back pressure is adequate. To monitor pressure, a 1/4 inch or 6 millimeter hole must be drilled into the vent work within 24 inches or 60 centimeters from the connection point on the tumble dryer. Note, when testing on a manifold vent system, all machines on the system must be running. When makeup air openings to the rear of the tumble dryers are insufficient, the tumble dryers will draw air from anywhere possible. This includes openings between other tumble dryers, through the control or coin drop, and the gap between the floor and the tumble dryer. A common visual result of a lack of makeup air is the accumulation of lint on the floor behind the tumble dryers that has been blown to the rear wall.
All right. So a couple things there, like just so we be clear, the video, we're trying to keep it short and sweet, and I get a little fast there with my commentary. Just understanding when your venting is not good, or there's a clog, or we got too many 90s, or the run is too long, or our manifold is not adequate. The tumbler is going to try and push air through that, and the fan's going to keep running. And the only thing we can really measure is if we keep blowing into that, eventually it's going to accumulate pressure in there. We can measure that pressure, and that's what we were doing. So we just want to take that a step further with a tool. We showed it in there called a manometer. This is a little bit different one, but a manometer can read vacuum or negative pressure, or static pressure. There's positive pressure, depending on which port you use. Obviously, when we're looking at vent work, we connect to the positive side to read, and we need a suction cup to see.
You guys want to see this, or I can just skip through this? Are you guys familiar with a manometer? I'll skip through it. We'll go back if you want it.
Add maybe 6 seconds on each side to remove the lint drawer. Add a half hour for you to find your key for the lint drawer. Don't forget that.
Mm-hmm.
That was a joke, Dustin. You were supposed to laugh at that, but you must.
Oh, I'm sorry.
Yeah, right. Yes, yeah, it's real believable. So
Yeah.
it's super simple. That's
I'm
what
an
it takes to
actor.
maintain. So symptoms of bad rollers would be you're getting a thumping noise, more of maybe a grinding or a metal on metal noise, or the cylinder just doesn't quite look right. That's your symptoms. I've seen people take their phones, reverse their camera, put it inside, shoot back at the roller to see its status, what kind of shape it's in. So that's a pretty good look at that. Moving forward, I'll always say this. If we've got any motor in the facility, whether it be a washer extractor, a small chassis product, or a tumbler, we need to vacuum the lint away periodically from either the louvers, holes on the motor casing to allow airflow through the motor to keep it cool. And then on this example, we're actually vacuuming the lint off the inverter portion of the motor, the heat sink.
So that's what you got to do.
Name there, heat sink. We want to keep that clear.
Nobody else is going to do it.
Dustin, we've gone through this a few times. I think you got it down by now. When
You're good at something.
is most of the lint in a laundromat produced?
It is produced mostly, not exclusively, but mostly when the load is already dry.
So in a tumbler, when the garments are already at, say, bone dry, or probably less than 2 or 3%, after that, if we keep drying, this is when most lint is produced. So I've had people say to me over the years, well, I'm a multiple store owner, And my venting, I've done a really good job on both stores, but this store just seems to have a little more lint than the other one. We find out it's habit. It's people have this tendency to add an extra quarter or extra time and just let the thing keep drying. We want to make sure they're dry.
Yeah, it's based on demographic,
Correct.
for sure. Everything. I mean, one laundromat in one location will have completely different occurrences. I'm sure some of you on this call probably can identify with that.
Yep. And just stuff to think about. Over drying is really hard on garments too for your customers if you ever want to let them know that. Yeah, of course we like the extra quarter, but we're getting more lint buildup and we're killing their clothes. When it comes to lint screen cleaning, there's just a few things I want to talk about here. I bring this up in every.
Someone just asked a question, just really pertinent
sure.
to what we're talking about.
Let's do it.
Can we auto stop the dryer once it's done? Set it to go into a cool down mode. So that sounds a lot like the auto sense, or the moisture
sensing.
Yeah.
And what a beautiful thing, and it is available on our non-vended products.
Some people, I mean, this has gone back and forth. I've heard many conversations about including it on vended products because it would save potential, utility costs and clothing. But in the vended environment, a lot of people have pushed back on that, saying that
it could hurt revenue.
It would hurt revenue. Yeah,
right.
Exactly.
But if I have a super busy store, which we all want, super busy laundromat, I have the potential of increasing my throughput, like get people in, get people out. If I can dry as fast as I wash, good Lord, we can really keep them moving. But that's a really good question, and it's a good thing, and it's, it's future looking is what that is. I do believe in time there will be a moisture sensing vended tumbler. I do believe that. I've thought that for almost a decade now. So, okay, thank you. And that was a good.
We have a lot of questions, so we have to make sure we have plenty of time.
Yep. Okay. So, two things with the lint. You should clean your lint screen daily at a very bare minimum. But if we ever see lint not accumulating on some portions of the screen, that means that screen is clogged with wax. Where did the wax come from? How am I getting wax into my tumbler, Dustin?
I don't know.
How is that possible?
Sounds like
candles in there. That's
fake. Yeah,
voodoo.
No, it's from dryer sheets.
Yeah,
and as they get more popular over time, they're also using a ridiculous amount of them. So people will throw 3-4 of them in a load, and it's really unnecessary to do.
Yep. And
so they're wasting time and causing you headaches by accumulating all of that wax in chunked areas on your lint screens, which someone actually in their PM response talked about how they're looking for consistency in the lint distribution on their screens.
They are looking for it.
They were, yeah.
Good. So if we see that, we got to get rid of that wax. The best way we've found over time is with really hot water or replacing the screens. One thing too, before we move on from this, unless you got more questions, Dustin,
we got a ton of questions. So
when we remove the lint screen, you saw there was felt lining on the sides of that. People ask me all the time, it's so hard to get the lint off that. How do I clean that? Don't is the answer. Don't clean that. That lint can stay there. It's basically, as we've discussed in the past, Dustin and I have determined, this is helping the cause. This is sealing the edge of that lint drawer so lint can't get past that down into your fan and your motor, your fan motor. So you got some other examples of what people have done for PM on this that you want to share with people? Okay.
Checking rollers, and then someone said, well, what does that even mean? What is a bad roller? What does it look like? What does it sound like? And what does it operate like?
So reviewing, it will give us either like a thumping noise, or it could give us more of a grinding, maybe scraping noise if we really let it go bad. Also, you can actually get a visual on it. If you just look at your cylinder, you know, where those rollers are at provide equal support. So if it's leaning one way or the other, it lets me know one of those rollers is in trouble. Also, in accordance to maintaining those two, we want to make sure we don't have anything wrapped around the roller. Like sometimes people forget they got like gold chains or necklaces in their pockets, and then they'll wash them, and then they'll get shook loose in the dryer and wrap with ourselves around the roller. What else you got, Dustin?
We got vacuuming lint screens and traps, the entire machine, back of the machines, checking lint for distribution. Yeah.
A non-OEM part from a store owner would call me in a panic. I got a whole bunch of my machines say EH paid for. Yeah, it was like error heat or a heat error. What that means is that the machine did not reach an expected temperature in an allotted amount of time. So basically, we knew we were supposed to be heating. The control knew that. So it's going to look, the temperature should go up within 5 minutes or so, or 2 minutes. If it doesn't, it's going to produce this very generic heat error code. For those of us with the new premium style, it actually goes a step further. But for across the board, here's things to look for if I ever see that. Like, hey, did somebody do some work on the machine and turn the gas off? Or is there a problem with the actual gas supply? Store owner would call me in a panic. I got a whole bunch of my machines say EHT. What's wrong with my machine? Chances are, if you're having a heat error across a bank of machines, there's nothing wrong with the machines. There's something wrong with the service to the machines. Yep. Something universal to all of them. Also, on non-premium machines, ignition circuit failed to light in the programmed amount of retries, meaning it didn't light, it tried to light, and however many times we didn't, or how many retries it didn't still make it. Eventually it'll just quit, and you just sit there and just keep turning, and eventually we'll get a heat error. And also we have something potentially wrong with the heat circuit itself or the gas valve. So again, for general understanding, heat error means that the machine did not reach the expected temperature in an allotted amount of time. This is actually an error code now that you can turn off just for measure. Sorry. EOP, error open thermistor circuit. So somebody asked us, Dustin, like why would I ever replace a thermistor? And this is what we need to start looking at. So we actually can generate two different error codes for the thermistor circuit. This first one, it says open thermistor circuit. Remember, the wires are just as important as the thermistor. So first thing we look for is, hey, is there a loose wiring either on a connector or a terminal that's somewhere between the control and the thermistor? Let's investigate that. Is one of those wires cut or rubbed, something like that? Did we do some mechanical service and didn't do things quite right? Finally, if we like the wiring, things are intact, it looks like it should, it generally means internally the thermistor is open. Then we need to replace the thermistor. This is the most common error on this particular circuit. But for a guy who's been around way too long, we don't see this error code nearly as often as we did with previous design. So Paul, I think, was the name we said before, Dustin. I think that's the name we said. He said, I would have a half dozen rollers in stock. I'd always have a couple thermistors in my laundromat as well, just to be sure. It's a simple fix. EOP, the wiring's good. Change the thermistor. We should be good to go. The opposite side of an open thermistor circuit is a shorted one. So when we look at that, look at these errors, what to look for. Looks pretty familiar, doesn't it? It's the same thing. So an open is when we read zero resistance. A short is when we read way, way, way too much resistance. The example I used in an earlier class is in a few weeks here, people in the north country, if they've never had a tumbler before, they're going to call technical support saying, it says ESH. And that's because, remember, cold air has more resistance. Well, they're so cold that they actually fall off our charts and produce this error code. That's cold, by the way, like -20. the last
Which isn't
couple
even that cold in Wisconsin.
No,
so.
that's like a normal January night in
Yeah.
Wisconsin. That's
Yeah.
that's a standard January evening for us. That's walk the dog with his coat on, right?
Yeah.
3 error codes actually
Put his
pertain
booties on.
with his little booties, yeah. So they walk funny. 3 error codes in reference to the airflow switch. Remember, we talked to you all got this right. Like the #1 most critical factor in drying clothes is airflow. So the airflow switch is important, and we monitor airflow a couple different ways through this switch now. So EAF, or if you have AFS, same thing, airflow or airflow switch. If we're flashing, let's see what happened here. Things to check, or that means that the airflow switch bounced 5 times during an active cycle. Bouncing meaning it was drawn shut and we got started, and then while it's running, the airflow switch is kind of fluttering. If we see that, we need to inspect our vent work right away. Something's wrong with the vent work, or we've got lint buildup. If it's not that, do we have loose wiring on the airflow switch? Remember, the switch is the very top of it. Is the fan working like it should? Is the fan motor turning? Is it drawing it in? And finally, the mechanical portion of the switch, is that intact? Remember the vane and the armature that held down? So that's one of the 3. The second one is EAF1 or AFS1. That means that the airflow switch fails to open at the end of the cycle, and it's actually monitored when you start a new cycle, meaning the switch is already closed when I start the cycle. Make sure the mechanical function of the switch is intact. Remember, gravity pulls that down. Is there lint buildup? Same thing. If we feel like all that's good and the switch just isn't doing its duty, it's probably internal to the switch. Just replace the switch. You don't have to replace the whole airflow switch assembly. You just need that little switch. And finally, the last airflow switch error code, EAF2, means that when we started the cycle, it never closed, meaning you've got something really the matter. Examples I've used over the years have been dead animals climbing into your vent. Somebody just crushed your vent altogether. The fan just doesn't work. That's all stuff we look obstructive vent work. Is the switch wiring completely off or something like that? Is the fan working? Is it mechanically compromised? So that would close out the error code section. Again, we have a resource for you here at the end to find all the proper error codes per your machine. But to close things up to everybody, entire audience, it is alliancedoc.net. Notice we did not put what in there, Gustin?
No www.
For basic knowledge, ED means something with the drive. Could you verify? Is it inside? Like when you say,
all right, that's it.
First of all, highly unlikely.
Issue?
Yeah, well,
know him. His name.
All right, you just witnessed what we had earlier. This was before this was during the pandemic. So this is some of the training that we had during the pandemic. Some of the webinars. I've given you the information. Speed Queen is owned by Alliance now. They own quite a few other brands. Everything is now under one umbrella. You have to go to the Alliance Laundry website. All the tech guides are there. Do hit the freaking like button, people. I really need that. Hit the like button. And maybe I'll come on later on tonight and cover some training that's going around the country. And with that, I will see you guys. I'll see you guys later.